Alright, the second method for solving algebraically is called elimination. This is explained in Beginning and Intermediate Algebra section 7.5. This method is useful when none of the coefficients are 1 and or both equations are in standard form. And so some students prefer the substitution method, but sometimes the substitution method can get really messy and the elimination method works better. So if both equations are already in standard form, the elimination method is very helpful. Or when the coefficients are not 1, when they're 2, 3, 4, some other number, it helps to use the elimination method. And some textbooks call this the addition method, so you might have learned it as the addition method or the elimination method. It's the same idea. So the idea behind this method is to add the equations together in a way that eliminates one of the variables. So sometimes they call it the addition method, other times they call it the elimination method. It just depends on the textbook. So we're going to again go through the steps for the elimination method, and then we'll go through a couple examples for the elimination method. And don't forget, you can always pause the video if you need more time to write anything down. Alright, so you might want to split your page into 2 columns. We've got the steps on one side and the example on the other. So the first step is to make sure that both equations are in standard form. If they're out of order or need to be moved around, that's the first step. Put both equations in standard form and vertically stack the matching variables. So the x's should be lined up, the y's should be lined up, and the constants should be lined up. And so vertically stacking the equations into standard form. From there, this part's kind of weird. Either the x or the y variables coefficients, one or the other, need to be the same value with opposite signs. The same value with opposite signs. And this usually requires some work. Usually you have to do something to make them be the same number with opposite signs. If we look at the example here, we have 2x plus 2y equals 14, and then 2x minus 2y equals 10. If you look at the x variables, they're the same number, but not opposite signs. If you look at the y variables, they're the same number, 2 and 2, but one is positive and one is negative. That's what you need, the same number with opposite signs. Once that's done, this is the weird part, you draw a line under the second equation and vertically add like terms. This should eliminate one of the variables. So this is kind of awkward if you haven't done it before. You draw a line under the equations and you vertically add them together. So 2x plus 2x is 4x. Positive 2y and negative 2y eliminate. And then 14 plus 10 is 24. So it's a very weird way to combine equations. But if you add them vertically and the numbers are lined up correctly, this should eliminate one of the variables. From here, you solve it, you plug in, and you state as xy, just like before. So from here, we're going to divide both sides by 4. X equals 6. And then we're going to plug in, and you can pick whichever equation you like. I personally like positive numbers, so I'm going to choose the top equation. 2 times 6 plus 2y equals 14. That's 12 plus 2y equals 14. I'm going to move the 12. 2y equals 2, divide by 2, and you should get y equals 1. So x equals 6, y equals 1, and you write it as an ordered pair, 6, comma, 1. So we're going to do just a couple examples of the elimination method. Some students prefer elimination, others prefer substitution. Really, you should be able to use both just kind of as they come, but if you have a preference to one or the other, that's fine too. Alright, so let's look at example 7 here. Then we'll do example 8 separately. Example 7, we have y plus 11 equals 2x. And 5x equals y plus 26. So these are not in order, they're not in standard form. We need to clean them up first. So if we have y plus 11 equals 2x, I know I need to move my 2x to the other side. And I'm also at the same time going to move my 11. Hopefully you can follow all that at the same time. So I'm going to move 11 to the right and 2x to the left, and that should give me negative 2x plus y equals negative 11. For these, you don't have to worry about that leading coefficient. It doesn't matter if it's negative. The second equation, let me put it over to the side, is 5x equals y plus 2. To fix this one, I need to move the y to the left. That gives me 5x minus y equals 2. So now I've got them both in standard form. I'm going to stack them up. Negative 2x plus y equals negative 11, and directly underneath it, 5x minus y equals 2. Once they're both in standard form and all lined up, then you check the coefficients. We have a 5 and a 2. Those are not the same, but they are opposite signs. Then we have a positive 1 and a negative 1, and those are the same with opposite signs. So we don't have to do anything else. We just stack and add. Negative 2x plus 5x is 3x. Positive y and negative y zero out. And negative 11 plus 2 is negative 9. So we divide both sides by 3. X equals negative 3. From here, we're going to plug into one of the original equations. You can use how they started. You can use how you adjusted them. It should give you the same answer no matter what. I'm going to use this one. Y plus 11 equals 2 times negative 3. So y plus 11 equals negative 6. I'm going to move the 11, and y equals negative 17. Alright, so we're going to put these together as an ordered pair. Negative 3, negative 17. And if you plug those into the originals, that should give you the correct for both equations. Alright, let's look at one more. I just realized I did not copy that down right. I am so sorry, I messed that up. I knew that didn't sound right. If you copy this down with a 26, just take off the 6 and just make it a 2. I'm so sorry about that. I don't want to have to make you do that all over again. We'll just stick with these two. It happened to work out. I just didn't copy over the 6. I just put the 2. Sorry about that. So just change that to that, and the correct answer should be negative 3, negative 17. I knew something didn't sound right. Sorry about that mistake there. Okay, last one. This one's a good one to just go over how to make them match if they don't. So we have 2x plus 3y equals negative 15, and 5x plus 2y equals positive 1. So this is a really good one to talk about how to make those coefficients match. You have a lot of flexibility in what you want to do here. You can really choose what you like. You notice that you have a 2 and a 5 and a 3 and a 2. None of them match right now. The x's don't match, the y's don't match. So you get to decide if you want the x's to eliminate or the y's to eliminate, and it's completely up to you. Once you make that decision, that will tell you what numbers to use. I'm going to choose to eliminate the x's. So for focusing on the x's, I have a 2 and a 5. So I know it's kind of like getting an LCD. This one needs to multiply by 5, and this one needs to multiply by 2. If I do that, they'll match. The other part of this is that one of them needs to be negative. And again, it's your choice which one you want to make negative. You can completely guess, it doesn't matter, you can just pick one. But what I'm looking at over here with this negative 15, I know if I multiply this by a negative, it'll get rid of that negative, which you guys know by now I don't really like negatives. So that's why I chose the negative on top. But it's up to you if you put the negative on the top or the bottom. And again, it's up to you if you choose x's or y's to eliminate. So lots of choices there. There's more examples in your book, but you can choose which variable you want to focus on and which one you want to make negative. And again, it's kind of like coming up with an LCD. You have to multiply by whatever it takes to make those numbers match. From there, You multiply through and multiply through. So you have, and I always put it to the side so I don't mess up where I'm at, negative 10x minus 15y equals, and I believe that makes it positive 75. And then positive 10x plus 4y equals 2. So again, they have to multiply all the way through to the entire equation. Alright, so from there, we've got those matching variable coefficients with opposite signs. So we can stack and add. The x's eliminate. Negative 15 plus 4 is negative 11y. 75 plus 2 is 77. Divide both sides by negative 11, and y equals negative 7. Now, most of the time you're going to get integers for these. You should not be getting fractions or decimals. They do exist, but I tend to focus on just integers. So if you're getting some weird answers, something might have gone wrong. From here, I'm going to take my answer and plug it back into one of the originals. I like this one better. You can use these as well, but these are smaller numbers. So you have 5x plus 2 times negative 7 equals 1. So 5x, that's going to become minus 14 equals 1. Add 14 to both sides, and 5x equals 15. Divide both sides by 5, and x equals 3. So my solution should be 3, negative 7, which it is. So again, if you need to pause the video, go back, watch it again, you can do that. If you need some more examples, there are more in your textbook. You can also YouTube this topic. It's a very common topic. There's probably a lot of good videos out there for the elimination method. Alright, so that finishes up substitution and elimination. I did put some extra practice online today if you need some more of that practice. We're going to move on to the final topic. So turn to a clean set of pages. This is going to be page 19 in your notebook. The review question, are the given lines parallel, perpendicular, or neither? This is a good review from what we covered in class. So we have 5x minus y equals 1, and x minus 5y equals negative 10. And so I'm going to leave this. We can go over this in class on Monday. I just thought it was a good example to go over. Then the reflection question, what 3 things do you plan to do to prepare for the Unit 1 exam? We'll talk about some different strategies and techniques in class on Monday and different things that you can do to prepare for the exam. So we'll talk about that on Monday as well. So that's page 19. Again, a review question and then a preparation for the exam question. Alright, so the last topic is something new, but it's very simple. It seems kind of weird, but it's a very simple technique. And it is called solving linear systems using matrices. And this is what homework 6C is about. This is page 20 in your notes. It's college algebra section 5.2. It's something that you only learn in college algebra, and you might see it again later in a different math class, but really it's just kind of a unique topic to college algebra. So when you have 3 or more linear equations with 3 or more variables, solving by hand becomes very challenging. And so we've been working with 2 equations and 2 variables a lot, but we haven't seen 3 equations with 3 variables. But when you have 3 or more, it becomes very complicated to try to solve these by hand. So instead of trying to solve them by hand, we're going to use what are called matrices. So matrices can be used to find the solutions. And so you picked up 2 purple handouts at the end of class. There's a full sheet handout and then a half sheet handout. We're going to focus on the full sheet handout first. If you have scissors, if you can cut right here before the word special cases, we're going to put this on 2 separate pages. So cut right underneath the last sentence in the middle, right above the word special cases. We're going to fill this in, and then I'm going to show you how to do this on the calculator, and we'll do a couple examples. If I run out of time, I will make a separate video for this. So again, cut right here, and tape down the purple sheet with the space you have left on that page. I'll give you just a second. You can pause the video and get that situated. All right. So a matrix with an X, a matrix is an organized chart, and sometimes it's called an array of numbers enclosed in brackets. So a matrix is an organized chart or array of numbers enclosed in brackets. Each number is called an element of the matrix. So you're going to see these square brackets with a bunch of numbers in it, and each number is called an element of the matrix. Matrices are organized by rows and columns. So it's like a very organized chart in rows and columns. The dimensions of the matrix are stated by the number of rows, then the number of columns. So it's R by C, rows by columns. Kind of like if you see a 2x4 piece of lumber, same idea. So a 3x4 matrix would have 3 rows and 4 columns. So rows go across and columns go down. And I remember columns, and they have an L in it, and L goes up and down, so that's how I remember that columns go up and down, rows go across. And when you see the little X in this notation, it's the word by. So a 3x4 matrix. Now it's always rows first and then columns, rows by columns. And I think of RC Cola to remember that. RC Cola, which is an old soda. I don't know if they make it anymore, but RC Cola to remember that, rows by columns. If you want to draw that again, if I'm going too fast, just pause the video. So we're going to make what's called an augmented matrix. An augmented matrix is 2 matrices put together with an imaginary vertical line separating them. You can draw the vertical line, but you don't have to. Just kind of know that there is an imaginary vertical line separating them, and it's called an augmented matrix. So to use a matrix with a system of equations, the system must be organized into standard form. Just like before, all the like terms should be vertically aligned. Then the coefficients and constants create what's called an augmented matrix. So you're going to have 3 variables now, x, y, and z, and they're going to equal a constant. So the x term, the y term, the z term, and then the constant. You're always going to have 3 equaling a single constant. So again, the coefficients and the constants create what's called an augmented matrix. So here's the example from your textbook. You have x plus 3y plus 2z equals 1, and 2x plus y minus z equals 2. And the third one is x plus y plus z equals 2. You'll be given that system of equations. The augmented matrix comes from the coefficients of each term and then the constants. So this coefficient on x is 1, so you put a 1. This coefficient on y is 3, so you put a 3. This coefficient on z is 2, so you put a 2. The constant is 1, so you put a 1. Then the next row, 2, 1, negative 1, 2, 2, 1, negative 1, 2. This is 1, 1, 1, 2. So 1, 1, 1, and then a 2. And there's that imaginary vertical line. Again, you never see that, but it is there to separate the coefficients from the constants. Alright, I'm going to stop there because I think the video is going to cut me off. So we'll stop there and we'll keep going with what we do with this to get to our answer.